Hello everyone, I am Daisy Jane Bicoy and we were going to discuss the types under first order differential equation. So first, we're going to discuss the separable differential equation which we are given with this equation dx plus y dy equals x squared y dy. So when we say separable, we need to separate x component from y component. So transpose y dy to the right, dx is equal to x squared y minus y times dy. Then dx equals to x squared minus 1 y dy dx over x squared minus 1 equals to y dy, and then integrate both sides. Since x squared minus 1 cannot be directly integrated, we need to use partial function. X squared minus 1 is equal to x minus 1 times x plus 1. So 1 over x minus 1 times x plus 1 is equal to a over x minus 1 plus b over x plus 1. Then we need to multiply it by x minus 1 times x plus 1. So 1 is equal to a times x plus 1 plus b times x minus 1 plus b times x plus a minus b. In order to get the values of a and b, we need to use the elimination method. So a minus b is equal to 1 and a plus b is equal to 0. Add both, eliminate b. 2a is equal to 1, a is equal to 1 half, then b is equal to negative 1 half. And then substitute it to the equation. 1 over 2 x minus 1 dx minus 1 over 2 x plus 1 dx equals to y dy. Then let u is equal to x minus 1, let v is equal to x plus 1. Substitute it over 2u du minus 1 over 2v dv equals to y dy. Integrate both. So 1 half ln of u minus 1 half ln of v equals to 1 half y squared plus c. And then substitute this to this equation. So 1 half ln x minus 1 minus 1 half ln x plus 1 equals to 1 half y squared plus c. Then by further simplifying, the final answer is y equals to square root of ln x minus 1 over x plus 1 minus 2c. So this is the final answer of the given equation. Our second given equation is y prime equals to secant y over x plus y over x, where y is equal to pi and x is equal to 2. So y prime is equal to dy over dx equals to secant y over x plus y over x. Then transpose dx to the right, so dy is equal to secant y over x plus y over x times dx. Since it is homogeneous differential equation, So y is equal to ux. Derive y, dy is equal to u dx plus x du. And u is equal to y over x. Substitute this to this given equation and this to this. So, since dy is equal to u dx plus x du, so u dx plus x du is equal to second ux over x plus ux over x times dx. Eliminate x, so u dx plus x du is to second u plus u dx. So we need to separate u component to x component. So transpose u dx to the right. X du is equal to second u plus u minus u dx. So this is eliminated. So x du is equal to second u dx. And then transpose second u was to dx over x. And then integrate both sides. Since second u is equal to 1 over cosine u, so cosine u du is equal to dx over x. So the integration of cosine u is sine u. So sine u is equal to ln of x plus c. Since u is equal to y over x, so sine y over x is equal to ln of x plus c. Substitute y is equal to pi and x is equal to 2. Sine pi over 2 equals to ln 2 plus c. Then we will get the value of c, which is 1 minus ln of 2. Then substitute this to this equation. Sine yx equals to ln of x plus 1 minus ln of 2. Then by further simplifying, the final answer is sine y over x minus 1 equals to ln x over 2. So this is the final answer for the given equation. Third given equation is y prime plus tangent of x times y equals to sine of 2x, where y is equal to 2 and x is equal to 0. So in a linear form of differential equation, we need to follow these three standards form. So dy over dx plus tangent of x times y is equal to sine 2x. In this equation, tangent of x is the p of x. So f of x is equal to e tangent of x dx. And the integration of tangent of x is ln of secant x. So f of x is equal to secant x. So substitute this in this equation. So the f of x is secant x. So secant x times y is equal to secant of x times sine 2x dx. So sine 2x is equal to 2 sine x cosine x, and secant x is equal to 1 over cosine x. So substitute this in this equation. So secant x times y is equal to integration of 2 sine x cosine x over cosine x dx. So cancel cosine x. So secant x times y is equal to 2 sine x dx. So the integration of sine x is negative cosine x. So secant x times y is equal to negative 2 cosine x plus c. So y is equal to negative 2 cosine x over secant x plus c over secant
In order
x.
to get the value of c, we need to substitute y is equal to negative 2 and x is equal to 0.
So negative 2 is equal to negative 2 times cosine 0 over 1 over cosine 0 plus c over 1 over cosine 0. So this is equal to 1 and this is also. So negative 2 plus 2 is equal to c. So c is equal to 0. Then substitute this to this equation. So y is equal to negative 2 cosine x over secant x only, since c is equal to 0. By further simplifying, y is equal to negative 2 cosine square x. So this is the final answer of the third given equation.
Is y prime plus y over x equal to ln of x times y squared, where y is equal to 1 and x is equal to 1, is a special order form of differential equation, which is the Bernoulli.
So dy over dx plus y over x is equal to ln of x times y squared. So in a special order, we need to use u, y, 1 minus n, where n is equal to 2. So u is equal to y negative 1 over, or 1 over y. So deriving u, du over dx is equal to negative y negative 2 dy over dx. And transposing it, dy over dx is equal to y squared du over dx, negative. So we need to substitute this to this equation. So negative y squared du over dx plus y over x equals to ln of x times y squared, and we need to multiply this to cancel out y squared. So negative du dx over xy equals to ln of x, and we need to multiply it by negative. So du over dx minus u over x, and since u is equal to 1 over y, and then negative ln of x.
As we can see, this is a linear form of differential equation.
We need to use
the linear form of solving this equation.
So in this equation, 1 over x is the p of x. So v is equal to e to the power of negative 1 over x dx. So v is equal to 1 over x. Substitute this, so d u of x is equal to negative 1 of x ln of x dx. Let u is equal to ln of x, and du is equal to 1 over x dx. So u times 1 over x is equal to negative u du. So u times 1 over x is equal to negative u squared over 2 plus c. Since u is equal to ln of x, substitute it. So u 1 over x equal to negative ln square x over 2 plus c. And since u is equal to 1 over y, so 1 over xy is equal to negative ln square x over 2 plus c. To get the value of c, we need to substitute y equals to 1 and x is equal to 1. So 1 is equal to negative 0 plus c. So c is equal to 1. So the answer is y is equal to 1 over x minus x ln square x over 2 or 1 over x ln square x over 2 minus x. So this is the final answer.
Our fifth problem is, what is the shape of a perpendicular cross-section of a horizontal throw of constant cross-section which drains so that the water level falls at a constant rate? This is the part of an application of differential equation first order. So this is an illustration of horizontal throw. We let this distance as y and this small strip as dy, and this is dx and dt. Since it is moving at a y direction or at vertical direction at a constant rate, so dy over dt is equal to k sub 1. So y is equal to k sub 1t plus c1. Since at y axis it moving at constant rate, so it is also constant at x-axis. So d square or second derivative of x over dt is equal to k sub 2. So since second derivative of x over dt is proportional to k square, so dx over dt is equal to k sub 2 t plus c sub 2, where x is equal to 1/2 k sub 2 t square plus c2 plus c3. Since along y and along x are in terms of time, so y is proportional to x squared. So the answer is y is equal to kx squared, which is having a shape of a parabolic. So the shape of the throw is parabolic. So that is the end of our discussion.